Hello, in this video, I'm going to introduce how to use the SMER music infilling model. You can see there is a Colab link and there is a GitHub repo link. In the GitHub repo link, there is a folder for the project file, and you can clone this GitHub repo or download a zip file directly. The zip link is also in the page. After the infilling files has been downloaded, there's an Ableton project file in the folder. You can open it using Ableton. You can see there are 3 tracks here: melody, bass, and piano. The infill model can be hosted on the Colab. We need to first mount a Google Drive so the GitHub repo for the model can be downloaded there. This model can be run anywhere. And here I just use the Colab to run it, because it can be quite easy if you don't have a server yourself. Here you'd better have a GPU to run this model. You can see in this Colab I use the T4 GPU. After the Google Drive is mounted, we can switch to the Google Drive folder and clone the GitHub file. You can see I didn't clone because in my Google Drive I already have that folder. It will be downloaded to SMER Music Generation folder from GitHub under the Google Drive. And then I click this button to install the software for this model. And then we need to get authorization token from nganok to expose the internal Google Colab IP to the outside. After we successfully get the token, we need to load the model. After the model is loaded, we can run the model. We can get a public URL here. We copy this URL and go back to Ableton Live. And in the box server IP, we copy that and click Connect. And for this plugin, if you want to use it, we first need to assign 3-track program. The first track we can set to flute, which is a melody. And the second we can set to bass. And third we can set to piano. And we click Show Info, which we can select the start bar and click the control calculation. We will get all the control parameters, including texture and tension. And we can have a listen to this existing song. You can see the track name is from track 0 to track 2. And the track 0 is melody. Track 1 is the bass. Track 2 is the accompaniment. For this plugin, we need to name 3 tracks as the name shown there. Track 0, Track 1, Track 2, and use underscore to separate track and their number. But for the clip name, you can set to anything like melody, bass, or piano. This song is one of the outputs of using this infilling model. We can listen to it. We stop listening to this song here and try to infill it. We need to select Start Bar, then calculate the control. After we get the control parameters, we can set what we would like to infill. For example, we can infill from bar 1 to bar 8 of the melody track, and click the Infill button. It will show in progress. After it's done, we can have a listen. Here we keep the bar texture, so it won't change the bar texture for those 1 to 8 melody bar. So you can see when a bar is empty, it's still empty after infilling because we keep the bar texture. What if we like to change the bar 6? We switch off the bar texture control, so it can generate notes. But if we keep the bar texture control, it's less likely to generate note because bar density is empty. We can generate several times for bar 6. Then we try to generate the bar from bar 5 to bar 6. Now we try to generate bar 9 to bar 10 without controlling the bar texture. Then generate from bar 11 to 14 using the existing bar texture. If we keep the existing bar texture, it will generate something similar to the existing bars. You can see the track texture control is density, polyphony, occupation at the left bottom. You can control those 3 track texture for the whole track. For the bar control texture, it is on the right lane. Then we select the start bar from 11 because we like to continue after bar 16. The window of this tool is 16 bar, so if we want to control bar 17, we need to select a different start bar, like bar 11. Now we generate from bar 17 to 22 over the melody track, using the existing bar texture. You can see I'm changing those things because I would like to have a different chorus part. Now the chorus part has been changed. We go back to the bar 1 to bar 16 by selecting the start bar 1, then click the control calculation again. Each time we change the start bar, we need to click the control calculation again. Here I would like to change the whole track too without keeping the bar texture and change it with 0 polyphony. You can see the first controlled is density, the second is polyphony, the third is occupation. Now it generates something with 0 polyphony. This generated piano track pitch range is very high, so we can manually shift down their pitch range by 1 octave. We select all the notes from bar 1 to bar 16 and shift it down 1 octave. The track can be rendered by any synthesizer. The trap name and the clip name will not conflict with any synthesizer. For the demo, we changed the melody and accompaniment track. Now we go to the bass track. We switch off the bar texture control, because if we keep it can be in conflict with the whole track texture control. This part doesn't sound good. We generate again, keeping the bar texture for bass track bar 7 to 16 bar. We can see after bar 17, it's the existing bass and accompaniment. After those simple operations, we generated a similar song to the existing song. I'd like to show how to use the bar texture control. I will infill the melody bar 3. And on the right lane, we change the bar 3 melody density from 3 to 6. Lastly, I'd like to change the bar tension for the bar 16 because the bar tension is calculated on all the notes in that bar. We need to infill all the tracks in that bar. We set it high and infill until it generates a high tension. It generates bar 16 with high tension now. Thank you for watching this demo, and I hope you can enjoy your playing this infilling model with fun.